So beta, again I am going to solve this numerical. So look at here. First of all, these two value is given. Higher pressure and lower pressure is given, but you can see in this case, pressure, both pressure is given and the value lower pressure and higher pressure, because lower pressure P1 is equal to P4, 1.05 bar is given in your numerical, and higher pressure, these two values is also given. Okay, this value is P3 will be equal to P2 8.5 bar. Okay, now the value of temperature. Initial temperature is given, T1 is equal to 10 degrees centigrade, and next value T3 is given 30 degrees centigrade. These two values is given, and we have to find out the value first of all T2 and T4. So these two value I have to find out. So T2, T4 I have to find out with the help of from isentropic compression process. Okay, so isentropic compression process, T1 by T2, that will be equal to P1 by P2 gamma minus 1 divided by gamma. The value of gamma is given 1.4. This is your equation number 1. From here you can calculate the value of T2. Okay, now again for isentropic expansion process, T3 by T4 is equal to P3 by P4 gamma minus 1 divided by gamma. So from here you can, because value of T3 is already given, so you from here you can calculate the value of T4 from this equation. Okay, now in this numerical, value of PV raised to power 1.3, value of n is already given, and everybody know what will be the value of gamma, that will be equal to 1.4. Okay, so by putting all these value, T1 minus T4 divided by N1 minus N minus 1 gamma minus 1 divided by gamma, T2 minus T3, T4 minus T1. By putting all this value in this equation, you will simply calculate the value of COP from this equation. So everybody solve this. First you have to find out T2, T4, then you can calculate the value of COP from here, from this equation. Hurry up.
Sir, answer कितना है sir? 1.3.
Yes, answer is 1.3. Very good. The COP system is coming is 1.3. Better next numerical. Write down the atmospheric air Can you see it on the screen? Third numerical?
Yes, sir.
Okay. So write down the atmospheric air at pressure 1 bar and temperature minus 5 degrees centigrade is drawn in cylinder of the compressor of a Bell-Coleman refrigerating machine. It is compressed isentropically to a pressure of 5 bar. In the cooler, the compressed air is cooled to 15 degrees centigrade. Pressure remaining the same. It is then expanded to a pressure of 1 bar in an expansion cylinder. Where it is passed to the cold chamber. Find number 1 the work done per kilogram of air. Find number 1 the work done per kilogram. Not air. Air is kilogram of air. Number 2, COP of the plant. Okay. So next, what is given for the expansion process? PV 1.2, not U. Here, PV 1.2 is equal to constant. Everybody note it. First, PV 1.2 is equal to constant. Number 2, law of compression given is PV 1.4 is equal to constant. And specific heat of air at constant pressure is given 1 kilojoule per kilogram. Everybody solve it. Hurry up. So, beta, how to solve this again? Look at here. So, look at here how to solve it. Pressure is given. How much pressure is given? 1 bar. P1 and P4 both are same. That will be equal to 1 bar. And temperature T1 is also given 5 degrees centigrade. T1 here 5 degrees centigrade converted to 78 Kelvin. Okay. Pressure second pressure is also given. What will be the pressure? P2 P3. That will also given minus 5 degree centigrade. And what will be the value of T3? Here T3 will be equal to 15 degrees centigrade. Okay. So here these value are given. So again you can calculate the value from this formula. T2 divided by T1, that will be equal to P2 by P1, gamma minus 1 divided by gamma. From here, you can calculate the value of T2. Number 2, again, for isentropic expansion, T3 by T4, that will be equal to P3 by P4, gamma minus 1 divided by gamma. From this equation, you can calculate the value of T4. But look at here, during your expansion process, now look at here. In this case, what will be the work done during your compression process? I have already told you, work done during compression process. In this case, work done during compression process, that will be equal to n upon n minus 1 into r T2 minus T1. T2 minus T1. Work done during compression process. And work done during expansion process from 3 to 4, n upon n minus 1 r T3 minus T4. In this case, you can take the value of gamma for compression process, which is already given in your numerical. The value of compression is, and you can write n upon n minus 1. That is also given in your numerical. What will be the value for compression and what will be the value for expansion process? Okay, both these values are given. So final work done, WC, work done by compressor minus work done by during expansion process. Okay, so now what is the refrigeration effect? Refrigeration effect will be equal to Cp T1 minus T4. Refrigeration effect. Okay. So both value you can find out from here. Work done and refrigeration. Now COP will be equal to how much heat absorbed. That will be the refrigeration effect divided by the work done. From this equation, you can find out the value of the COP. Okay. Here the value of T1 is minus 5 degrees centigrade. Minus 5 means 268, which is given in your numerical. And 1 bar (15 degrees centigrade). 15 is your T3. That's correct. Here is minus 5, not 5. Minus 5. So calculate the value. Everybody calculate the value. First of all, you have to find out the value because T1 and T3 value both are given in your numerical. So first of all, you have to calculate the value of T2 and T4. Okay. So from T2 by T1 is equal to P2 by P1 raised to power gamma minus 1 upon gamma. From this equation, you can find out the value of T2. And from second equation, T3 by T4, you can calculate the value for T4 as T3 is given in your numerical. Okay. Now next is given what is the work done by the during compression process. That will be equal to n upon n minus 1 into r T2 minus T1. Okay. And work done during expansion process. That will be equal to n upon n minus 1 r into T3 minus T4. So net work done, difference of both compression process and expansion process, and a refrigeration effect, how much heat is extracted, that will be equal to at constant pressure Cp T1 minus T4. Now next COP, as everybody know, refrigeration effect divided by work done, that will give the COP. So this is the method how to calculate, how to find out the value of COP. So everybody, you must find out the values. Hurry up. So note down the value beta T2, that will be equal to 4 to 4.8 Kelvin. And the value T4 comes out to be 220 Kelvin. And work done by the compressor, that will be comes out to be 159 kilojoule per kilogram. And work done during expansion, that will be equal to 118.3 kilojoule per kilogram. Net work done will be equal to difference of both the compression and expansion process is equal to 40.7 kilojoule per kilogram. And COP of the system, first refrigeration effect, that comes out to be 48 kilojoule per kilogram. And COP of the plant, that comes out to be 1.18. That will be the answer. Now, beta, I am going to release the poll. So your very first poll, I am going to launch the very first poll. Answer it within 2 minutes. Okay, hurry up. But everybody must answer this question. Hurry up within 30 seconds. I am going to end this poll after 10 seconds. Hurry up. But I am going to close it. So answer is your Bell-Coleman cycle. Next poll. In PV diagram of Bell-Coleman cycle, 1 to 2 process is known as ਉਹਨੂੰ ਕਿੰਨੀ ਵਾਰ ਕਹੀਦਾ ਬਣਾ ਦਿਓ ਕਿੰਨਾ ਟਾਈਮ ਹੋ ਜਾਂਦਾ ਰੋਜ਼ %71% student already voted. Only 29% students still there who did not vote yet. Hurry up. Make it fast. I am going to end this poll after 10 seconds. So your all answer is correct. Next poll. Hurry up. 3 to 4 process is known as on PV diagram of Bell-Coleman cycle. Only 1 minute time is there. Hurry up. Hurry up, please. I am going to end this poll after 5 seconds. All the students must vote it. Hurry up. End this poll. Answer is correct. Isentropic expansion. Next. Bell-Coleman cycle is also known as answer within 1 minute. Hurry up. I am going to end this poll, beta. Hurry up. Next poll. Everybody must hurry up. Which of the following is not a true advantage of Bell-Coleman cycle? बेटा अपने माइक बंद कर लो तो everybody stop their mic. Hurry up, beta. I am going to end this poll. Hurry up. So beta, air is easily available. It is safe as it is non-flammable. It is not toxic and non-corrosive. It is also true. The weight of the air refrigeration equipment per ton of refrigeration is much more in an aircraft than other refrigeration system. This is not true. Okay, so this is not part of your this question. Okay, so D is the wrong answer. Next, last one. Bell-Coleman refrigeration cycle uses dash as a refrigerant. So which refrigerant is used in Bell-Coleman refrigeration cycle? Coolant, carbon dioxide, air, hydrogen. Water, not hydrogen, but it's water. Coolant, carbon dioxide, air or water? But I am going to end this call. Hurry up. So the answer is air. Okay. So beta, your next session start after 15 minutes. Okay. 3:30. At 3:30, I will start next session of your lab. Okay, beta. So join me from another login ID. Okay, which I have already sent to you. I'm going to send to you.